In this video cast, we'll look at several special elements, then we'll look at the formation and composition of ions, and how ionic compounds are made. First of all, some special elements. If you don't have a periodic table out, please do take it out at this time. The special elements I want to show you are ones on the periodic table that when they're alone and by themselves exist as pairs. These special elements are called diatomic elements, coming from the prefix di meaning two and atomic meaning atom, which means that they exist in pairs or two atoms together. The atoms that do this can be symbolized as Br, O, H, N, Cl, I, and F. And if you want to say this as a word, it's the word Broncliffe. These all exist diatomically, and when you write them, when they're alone by themselves, you always put a small 2 down below, illustrating that there are two atoms stuck together. These are also known as the sneaky 7 on the periodic table. The reason they're known as the sneaky 7 is because they're located in such a place that they form a 7 on the periodic table. 6 of them come together to make the 7. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And then it's sneaky because hydrogen is also one of the 7 diatomic elements. When you write these once again, for example, the element hydrogen must be written as H2 when it's alone by itself. Chlorine must be written as Cl with a small 2. Remember, it's when they're alone, not combined with something else, and we'll combine lots of things today. We'll combine lots of things today and in the future. The nucleus of an atom is unchanged by chemical processes, but atoms can readily gain or lose electrons. This gaining or loss of electrons, this gain or loss of electrons, causes something to become what's called an ion. An ion. An ion is something that has a charge because it's gained or lost a negatively charged thing. If you remember back to last video cast, electrons, symbolized by E with a little negative 1, have a negative 1 charge. And mathematically, when we deal with that, we say electrons have a negative 1 value, or a negative 1 charge. Now, take for example a sodium atom. A sodium atom, if you look on the periodic table, has an atomic number of 11. If you look right here, here's sodium, and it has an atomic number of 11. It has 11 electrons around it. So if we symbolize this as like a circle of electrons going around it, it has 11 of them. Now, sodium atoms generally tend to want to lose an electron quite easily. And if one electron goes away and is given away to something else, we now have one less electron. And in mathematics, when we say we lose a negatively 1 charged thing, what is minus a minus 1? Well, of course, it's positive 1. And so when sodium, or some other element, has lost an electron, we would write its symbol as Na positive 1. Now, if we wanted to write the complete symbol, of course, and we knew what isotope we were talking about, we'd put the number 11 down here below, indicating that it has 11 protons. And if we knew it was the isotope that had 12 neutrons, we'd write 23 up here on the top. But this number right here tells us what kind of ion has formed and whether something has lost electrons or whether something has gained electrons. Conversely, let's look at the element chlorine. If you look at chlorine on your periodic table, chlorine has 17 electrons, or 17 protons too. But remember, the nucleus isn't affected by reactions. So if we drew this as like having 17 electrons spinning around the outside of the nucleus, chlorine is one of those elements that likes to gain electrons. likes to gain electrons. And in mathematics, when something gains a negative thing, we write it like this: plus a negative 1 thing. When you add a negative 1 to something, what does it become? Well, it becomes a negative 1 charge. And so when we write the ion of chlorine that has gained an electron, we now write it as Cl with a little minus sign, or a -1 in the upper right hand corner. This is the symbol for an ion of chlorine. Now if we wanted to write the complete configuration of this, we would have to put the 17 down in the lower right hand corner, indicating it as 17 protons. And if we knew what isotope it was, we'd put, for example, a 35 in the upper left hand corner, meaning that it would have 18 neutrons. Now we might not know these things all the time, which is okay. Well, we'll always know the protons, but we might not know what isotope it is. What's important, and what we'll be dealing with a lot, is what this charge is. This charge is because something is gained or lost electrons, and that gaining and losing of electrons is critical to the formation of many, many chemical reactions. So how can we predict whether something on the periodic table will gain or lose electrons? How can we predict this? Well, by looking on the periodic table, what many atoms want to do is to end up with the same number of electrons as the noble gas that's closest to them on the periodic table. The members of the noble gas family are chemically non-reactive and form very few compounds. And we'll look closer at this in Chapter 6 and Chapter 7 as to why, energetically, those things don't actually do this. So if we take a look at where sodium is on the periodic table, sodium is element number 11, we can see that the noble gas that's closest to it has 10 electrons, and it's the noble gas neon. That's why sodium wants to lose an electron so that it can look like neon. Chlorine, on the other hand, has a neighbor called argon that's a noble gas. And notice chlorine has 17 electrons, and it wants to become more like argon, and therefore it gains an electron. Now if you look at all of these elements in the periodic table, to find out what charge or what ion they will usually become is quite simple. You simply want to add or lose electrons to become like the noble gas that's nearest it. For example, all the fluorine, chlorine, bromine, and iodine atoms generally want to gain an electron. And remember, when you gain an electron, you have a -1 charge because you gained a negative thing. They need one more to become like neon, or like argon, or like krypton. Oxygen, sulfur, selenium, and tellurium, on the other hand, they're 2 away from becoming a noble gas. And so generally what they want to do is gain 2 electrons, and they generally have a -2 charge. Nitrogen, phosphorus, arsenic, for example, are 3 away, 1, 2, 3 away from becoming a noble gas configuration, and therefore they generally will gain 3 electrons. And remember, when I say gain, the reason it's becoming a negative charge is because it's gaining 3 negative things. Carbon, silicon, they're 4 away, and so sometimes you'll see them as -4, but conversely they could go backwards too, because look, it's also easy with carbon with 6 electrons to go 5, 4, 3, 2 and become like helium, and so sometimes we'll say it'll be plus or -4. As a matter of fact, we'll find out that these numbers are not absolute. There are other charges that these can form. Boron's group, on the other hand, isn't that close to neon anymore. Now it would have to gain 5 electrons to become like neon, but what it could do is go down to look like helium, which has 2 electrons, and it would have to go 5, 4, 3, 2, it would have to lose 3 electrons, and when something loses 3 negative things, remember that's minus a -3, it becomes +3, and most things in this group or family right here are a +3 charge. Look over here at these, you notice beryllium to become like neon I'm sorry, to become like helium, it has 4 electrons, would want to lose 2, and losing 2 gives you a positive 2 charge, and these guys right here are almost always positive 1. Almost always positive 1. These charges that I've written on the top must be memorized, and hopefully just by looking at a periodic table you can figure it out that group 1s are plus 1, group 2s are plus 2, group 13 are plus 3, 14 are plus or minus 4, 15 are minus 3, 16 are minus 2, 17 are minus 1. Write this on your periodic table right now. Pause the video and write it on your periodic table if it's not already there. Well, when 2 things that have gained and lost electrons come together, they form what's called an ionic compound. An ionic compound consists of a positive ion and a negative ion. A positive ion and a negative ion. And there's some special names given to the positive ion and the negative ion. The positive ion is also given a name called a cation. I like to draw it like this. Here's my chubby cat who has to go on a diet pretty soon. He has some positive eyes, and he has a significant amount of belly drag, and he has a nice long tail. Anyway, notice his eyes are positive. His eyes are positive, and that's why I can call him a cat ion, because he has positive eyes. Conversely, the negative ion is known as the anion. The anion, sometimes you can draw this little critter and just kind of make believe that, you know, he's negative, so he has 2 negative eyes, and he's not very happy. And he has some legs here, and you could maybe call him the ant-ion, maybe. Anyway, you can see that the difference is the cation is positive, and the anion, don't use the T, it's not really supposed to be in there. The anion has negative eyes, or is negative. Now the cations are 99% of the time metals. Metals on the periodic table, and this is why it's so important to know where the metals are on the periodic table and identify them in a snap. The anions are most of the time nonmetals, or they're combinations of metals and nonmetals that have an anion or a negative charge. When a metal and a nonmetal comes together, it forms what's called an ionic compound. And over the next few videocasts, we will look at naming many of these metal-nonmetal combinations, which are called ionic compounds. The naming of these things is known as nomenclature. And it will become very important for you to become very good at ionic compound nomenclature. And first of all, recognizing that positively charged metal and negatively charged nonmetal, or something that 2 or more things come together, make an actual name. One last thing before we're done. I alluded that many anions, or I should say some anions, contain 2 or more things stuck together. These 2 or more things that are stuck together are known as polyatomic ions. Poly meaning many, atomic meaning atom, and ions meaning something that has gained or lost electrons. Now, there are polyatomic ions that are negative, that are anions, and polyatomic ions that are positive. On page 62 in your text, it outlines a number of common positive ions, and on page 64 in your text, it outlines a number of negative or anions. Now, anions are the more common ones that forms what are called polyatomic ions. Cations, there's only a few. An example of a polyatomic cation would be NH4 with a positive 1 charge. Notice it's not a metal. It is 2 or more elements that have come together to form a positive charge, and this is one of the exceptions when you can have an ionic compound where you don't have a metal in it, when it has this as a cation and then a non-metal anion. On page 64 you can see a number of anions. For example, C2H3O2 with a -1 charge is known as the acetate anion. It has a -1 charge. ClO3 with a -1 charge is known as chlorate ion. PO4 with a -3 charge is known as phosphate anion. And you can see many of them, and over the course of the next week you will memorize many of the names and formulas of these common polyatomic ions. Not because I want you to, but because the College Board, in their infinite wisdom, believes that you need to become very, very well versed in the language of chemistry, and polyatomic ions, formulas, and charges are part of that language. Good luck with your ionic nomenclature.